Let's start the first question. In this question, we are asked to implement a student class with the following members. And these members are, first is the name of the student, and the age of the student, and the GPA of the student. And we need to implement a constructor and getters and setters. For these display details, I think it is already in the template code. So we just need to implement these three. So first, we need to define the private members, which is a string of name, and age is an integer, but GPA needs to be double. And then let's implement the constructor. The easiest way to implement this constructor is using copy. So it will be name equal to student name, and age equal to student age, and GPA equal to student GPA. Yeah. However, actually, if you write this code in the exam, you will get correct. But I think you may learn in the lecture that the best way to implement the constructor is using like this: name, student name, and age, student age, and GPA, student GPA. Yeah, I think this is the best way to implement the constructor, which is because using this way, the variable name is created use this student name. But if you use in the previous way, the system will firstly create the name and copy the student name to this name. So if you are doing this code, you will be calling the constructor when creating the name. But in this code, you can see that for this string, actually it can be a reference because this string may be a very large data. So you can use code by reference to optimize this code. And if you are familiar with modern C++, actually there is a function called move. Yeah, and this will be better. And to see the details, you can read the notes. And so here, I think we can just do like this. And next, we move to getters and setters. For the getters, yeah, it will be void get name, and it will be it's std string return name int get age return age, and double GPA return GPA. Yeah, and it will be definitely correct. But again, you can see here, when you return a name, yeah, actually it will cause a copy, which is the name copied to the return value, and the return value copied to the following code. So the best way is to use return by reference. And again, because this function needs to be a const function like this, so it is better to add a const. And if you don't know what is the const function, you can read the notes. For the setters, it is easy to directly use set, or this is get GPA, and set name, which is you can use call by reference. And actually you can use move, but it is optional. Yeah. Equal to name and void set a. Yeah, it is they are the setters. So this is the solution for the first question. Next, let's see the question 2, which is the copy constructor. In this question, the code is given to us, but it has a bug. The code defines a visitor counter, which counts how many visitors in the website, and it is defined a count, which is a pointer, points to some value. And at first, when the pointer or visitor counter is constructed, it will create a new integer and let count points to it. And when the visitor counter is deleted, it will delete this value, and this is the increment and display. But you need to know that in this class there is no copy constructor defined. So let's see what will happen. In the main function of the code, at first it create a counter with count equal to 10, and then it will do a copy. However, in this code, actually it is a copy constructor instead of copy operation, and it will do an increment and display. So the main issue is there's no copy constructor defined. Let's see what will happen. Because copy constructor is not defined, so the compiler will generate a default one. In the default copy constructor, the compiler will write like if it do copy, it will copy everything, like it will copy every member's value to the other data. However, for a pointer, the value of a pointer is the address instead of what it points to. So it will only copy the address like this. Now there's a counter and it points to this value. When it do this, counter equal to copied to counter copy, so it will create a new one. However, because this is the default copy constructor, here it will directly copy the address to this. So both of them point to the single data. Now, when you do the counter copy.increment, it will increase this value. And here you can see that because these two point to the same data, so you can see the counter.count is also this data and it's also increased. So when you do counter.display, it will display 12 instead of 10. And another thing is, remember when you write the when the code writes the deconstructor in the copy in the counter, it will delete this count value. So when the main ends, the deconstructors will run in reverse order. At first, for the copy counter, it will directly delete the count and free this place. But when you delete this counter, it will also free this. Yeah, so it will cause the undefined behavior. So for the summary of the issues, the root cause is the default copy constructor copies the pointer's value, which is the address, instead of the point to data. So it will cause unintended sharing, which is both of them point to the same data, and double free, which is both deconstructor will delete the same memory and will cause error. And again, actually, in this code, there is another bug, but which is not mentioned, which is no copy assignment operator. You need to know that copy constructor and copy assignment operator, they are not the same. So for example, if you do A equal to B, you will call the assignment operator. But if you do this code, if you do code like this, you create this data copy counter copy, and you do this. Actually, it calls the copy constructor instead of copy operator. But actually, they are mostly the same. So we need to implement both. So the first thing is we need to write a deep copy constructor, which is here we need to count equal to new int. So every time when you copy the data, it will also create a new count and create a new data, save this. And also we need to write this copy assignment operator. But in copy assignment operator, we need to check if the code is written in A equal to A, which is the same like self-assignment check. If A equal to A, you can do nothing. But if it is like A equal to B, you need to copy the value, which is the count value, copy to itself. So actually, there is a rule called the rule of 3, which is if the class needs any one of these, you need to check most of the time, both of them need to be implemented, which is deconstructor, copy constructor, and copy assignment operator. So this is the complete fix. Same constructor, but another constructor of the for the copy constructor, and this is copy assignment operator. And now actually more and more people realize that for this copy constructor and the copy assignment constructor, actually this is not a very good design. So in modern C++, there's a thing called smart pointers to solve this problem. So in C++ 11, they introduced the smart pointers in this memory, and this will automatically manage the lifetime of a heap allocated objects. So there is unique pointer and shared pointer. For the unique pointer, if we rewrite this code, we can see that here is the unique pointer. So every time it will make unique, which is like our new. So in this code, there's no deconstructor needed. So unique pointer will auto delete the value, and no copy constructor needed because copying is blocked at compile time. However, sometimes you need to you need to let two classes or two pointers point to the same data. Here, we introduce the shared pointer. For this shared pointer, actually, the data will automatically count how many shared pointers point to the same object, and if the memory is freed, only when the count reaches 0. So there's no double free. So actually, in modern C++, we prefer smart pointers instead of new delete. In this question, we are asked to write a class called pen, and there are two members: the color of the pen, which is a string, and the price of the pen, which is a double. And here we need to write three functions, two setters and one display. For the display, it is very easy. We just need to follow the same sample output. So it is output the pen color and this color and price of the color, which price of the pen, which is price. And this is the display function. Now we need to implement the setter. And for the setter, actually, it is mostly the same as the question one. You just need to do color equal to new color. Or actually, you can do std move new color, but this is optional. And you can do price equal to new price. So it is the best to write std move, but you can ignore it. However, in this question, we need to support the method chaining, which is if my pen dot set color, it can also write dot set price. But actually, this is very easy. You just need to return this. So every time when it calls this function, it will return itself. So after it sets the color, it will return my pen, and it will do my pen dot set price, and finally it will display. Yeah, so this is a very easy question. Here we still need to return this. Okay, now we get the correct answer. Okay, let's do the final question, which is he asked us to develop a box class, and there are three members, length, width, and height, and we need to calculate the volume and display the dimensions. So let's see the code. There are three private members already defined and constructor already defined. So at first we need to write the calculate volume, and this is very easy. We just need to double V equal to length times width times height, and we need to see out the V, but we need to check the sample output, which is we need to write it like this, and here is V. There's the V. So this is the calculate volume. And next, we need to write the display dimensions. So he has asked us to define this as a friend function. So it is an external function. Yeah. And in this function, we can see the sample output to know how to write it. So first is the box dimensions. And we need to output the length. And width is width and height. Width. And the final is the height. I want to mention that here I type it directly, but sometimes I recommend you to direct copy this here. So you will not get like you will not get typo, because for the apath it will compare the output directly, and if you type in a typo, it will get you a wrong answer. So it is best to do copy paste. And here, because we can find that, we can find that here the member is inaccessible, which is because here they are private. So we need to define declare the friend function. You can check. Yeah, this is private, and if we define the friend void display, yeah, if we define this, there will be no error, and you will get the answer. And you can find there need to be an end line here, so it is better to output std end here. Yeah, so this is the answer for question 4.